Okay, here we are in section 9.3, two dependent samples, matched pairs. Okay, so look at question number 1 here. The following data list the ages of a random selection of actresses when they won an award in the category of Best Actress, along with the ages of the actors when they won Best Actor. The ages are matched according to the year that the awards were presented. So in other words, this is the same year. Maybe this is, I don't know, 2018. Just guessing. The actress that won for Best Actress was 28 years old. The actor was 58. And this was the year 2017. The Best Actress was 30, who won that award, was 31 years old. The actor was 34. And this is 2016, etc. The point is, these two data sets, this is going to go in L1 in our calculator and this L2 like usual. No surprise there. But this data is dependent. That's what this section is all about. Dependent. They're called matched pairs because they come in pairs like husbands or wives, actresses and actors. We'll see other examples that are not just men and women, but they're related. Like there's a connection between the 28 and 58. They were in the same year. And the 31 and the 34, they were in the same year. So these are matched up. These data sets are related to each other. They're matched. They're dependent upon one another. They're not independent like the last section. 9.2 was independent. That would just be if you grabbed, like 10 actors and 10 actresses at random from all different years, not matching them up at all. That would be independent, two totally independent groups. And then you answered some questions about it. But now we're matching them year by year. This is a dependent two dependent data lists. They're matched pairs. Okay, so you'll need to recognize that on exam number 4. I think you can spot it pretty easy. They're clearly all matched up. So what do you do about it when they're all matched up like that? Well, you're going to have to handle it a little bit differently. Let's go look at exam 4 notes. So here they are. This is exam 4 notes. So remember, this is section 9.1, two proportions, 9.2, two independent means, and 9.3, two dependent matched pair means. That's what we're talking about now. How do you do it? Data's in matched pairs. Actor, actresses, couples that are male, female, subjects before and after, etc. Put the data in L1 and L2. So that's the first thing. Let's go back here. So take your calculator. Let me get rid of this. And we'll say OK. We're going to go to Stats. Or hit the Stat button on your calculator. And go to Edit. Go to the top of L1 and hit clear and enter to clear out L1 and put this data in L1, put the other data in L2. Put the data sets in L1 and L2. So that's the first thing. Now, after you're done with that, hit second quit. Exit that data scene. So here we are. Put the data in L1 and L2. And then quit out of that. And we're going to put in L1 minus L2 store L3. So that's new. So now what we're going to do is after you quit and you're out of that screen, we're going to go second 1 minus second 2. Oh, here, I'm running out of room. Let me scoot this over here. We're going to go second 1 minus second 2 store. So that's into second 3 there. That's a terrible 3. Okay, so what's going to show up on my screen is L1 minus L2 stored into L3. So basically what we're going to do is we're going to take the differences Because that's what we're really looking at here. We're looking at the differences. I'll put it down here. The differences. Meaning, what's 28 minus 58? That'd be negative 30. And what's the difference 31 minus 34? Negative 3. 33 minus 32, positive 1. 30 minus 42, negative. So see what I'm doing? I'm taking the top number minus the bottom. Top number minus the bottom. I'm usually getting negative. Top number minus the bottom, positive, a regular 9. Top number minus the bottom, negative 4. Top number minus the bottom, negative 3. Now, a calculator is going to do this automatically for us. We're not going to actually do it by hand. When you type in L1 minus L2, store into L3. By the way, the store button is on the bottom left of the TI calculator. It's second row from the bottom on the left. So anyway, so we're going to store up. We're going to subtract L1 minus L2 and store the answers in list L3. That's what that's going to do automatically. So we put all of our data. We put our data into L1 and L2, and then we quit out of there. And then back on the main screen, we're going to go second 1 minus second 2, store into second 3, which is L1 minus L2 stored into L3. So all these differences, 4, negative 6, and negative 6, these differences are now stored in L3. You don't have to look at it, but you could go back if you wanted to go back and hit data and edit. You would see that now the calculator put into L3 these differences. It's subtracted, because this is list 1, this is list 2. It subtracted L1 minus L2. It's taking the differences, because we're trying to find out if there's a difference in the ages between the best actress and the best actor year by year who get these awards. And so you have to take the differences. You got to do the subtractions. So 28 minus 58 is negative 30, etc. So we got all these differences. And then now, so getting back to it, so put the data in L1 and L2, second quit, take L1 minus L2, store it in L3. Now L3 has everything we need. It's got these differences. L3 is going to be what we work with at this point, because it's got the differences stored in it. Okay, so now what's the claim on this problem? Is there a claim somewhere? I don't see the words claimed. Oh, here it is. So I've kind of made too big of a mess here. To test the claim that for the population of ages, best actors and best actors, the differences have a mean less than 0. So there's the claim. So the claim is mu sub d is less than 0, meaning the claim is differences well, if you look at these differences right here, here's these are the differences, right? Whoops, I missed that last one. These are the differences between the actress age minus the actor. Those are the differences. The claim is that the mean, the average of those differences, is less than 0. That's the claim, meaning that the actress is younger, which they usually are, right? Because if you subtract two things, if you take L1 minus L2, and this is the actress minus the actor, and you get something less than 0, something negative, right? Less than 0 means negative. Numbers that are less than 0 are negative numbers. So if I subtract two numbers, how do I subtract two things and get a negative answer? Well, the first one's got to be smaller. Second one's got to be bigger, right? That's how you get a negative answer. something less than 0, like -2. 7 minus 9 is -2. That's less than 0. So the only way you're going to subtract two things and get a negative answer is if the first one is lower, if the actress ages are usually lower than the actor ages, you get negative. See how most of these are negative? Not always. Usually, though, the actress is younger, like 26, and the actor is older, like 56. Usually, not always. There's a couple of exceptions, but usually, like there she is, she's 33, the best actor's 39. So usually the actress is younger, so usually the differences, most of them are negative. A couple of them are positive, but most of them are negative. So the claim is that the mu sub d, that's a new symbol, that stands for the mu is always average, right? That's the Greek m for mean. The average of the differences, that's why there's a subscript of d down there. The mean of the differences, the m of the d, the mean of the differences is less than 0, meaning negative. We're claiming that the average difference is negative, meaning that the actress, on average, is younger than the actor. So when you subtract them, the first number is small, you subtract them, you get a negative. That's what's being claimed. Okay, so how do we write that? Well, you know that the null hypothesis is always equal. So we're going to say the difference, the mean of the differences is equal to 0 versus the mean of the differences is less than 0. That's what they're claiming. They're claiming it's less than 0. So the mean of the differences is less than 0. So the null is always, and so the claim is here. The claim is on H1. I shouldn't circle that. We don't know if that's right yet, but that's where the claim is, because that's what they're claiming, that the mean of the differences is less than 0. Okay. So, how do we put this in our calculator? Let's get to a fresh screen here. So, this was equal to 0, less than 0. This one's the claim. All right, and so we've already put this in L1, put this in L2. We've said L1 minus L2 is stored in L3. So now L3 holds our data. All right, let's go back to our sheet. Data in matched pairs. Put the data in L1 and L2. Then do L1 minus L2 stored in L3. We did that. Now do t-test or t-interval. Notice we're not doing two-sample, are we? We're not doing two-sample. Why not? Because all of our data is now in one list, L3. Right? We already subtracted the numbers. It's all in L3 now. The differences, because they're matched pairs. They're matched up. So we subtracted them and got negative 30. And subtracted them and got negative 3. And subtracted them and got positive 1, etc. And those are the differences. Those are now in L3. All these differences are now in L3. L1 minus L2 stored in L3. So we don't have two samples anymore. We just have one list in L3. So we just do t-test, not two sample. Because we're just dealing with one list now. Let's go back. So we do t-test. In a minute we'll do confidence interval, we'll do t-interval. So t-test, choose data. Mu0 is 0, list is L3, because that's where our data is. So let me go back. So you choose, when you go to t-test now, you choose, when it says, where's your input coming from, you choose data. Your input's coming from data. And your mu0, what's your mu0? Where do we always get mu0 from? Where do we always get mu0 from? What does that little 0 remind you of? The H0, right? You always get whatever number is at H0, that's going to be 0. The list, now where's your list of data? It wants to know where's your list of data. Pay attention here. This is where you got to do L3. Does everybody see that? L3, not L1 or L2, right? Because now all the differences are stored in L3. So the list of data that we're going to grab is L3. So you got to change that, make sure you're right on that. Frequency is 1 always. So, and then are we doing a less than, greater than kind of test? We're doing a less than. So choose less than and calculate. When you do, let me see, I'm getting a t value that is negative 1.86. That's my test statistic, and my p value, that's 0.048. All right, so the question is that p value less than significance level? There's the significance of 0.05. Is that less than 0.05? Yes, it is, just barely. So if the p is low, it is low. The HO must go away. So bye-bye, null, and we'll keep the H1, which is the claim, which means there's strong evidence whenever you're going with H1. So we believe the differences, the mean, the average of the differences is less than 0. When you take actress minus actor, you usually get negative numbers. And we believe there's strong evidence for that. Not just, it couldn't have been luck. I mean, there's a less than a 5%, there's a 4.8% chance that these numbers just could have been lucky years. So that's not a very good chance of luck. It's probably really true that on average, the actress age is younger than the actor, so that when you subtract them, you get a negative number, a number less than 0. The difference is less than 0, meaning it's negative, which means the actress is a younger number, like she's 27, or like she's 28 and he's 58. So you get a negative number when you subtract, number less than 0. So we believe the claim, strong evidence for that. Let's answer that. So since the p-value is less than or equal to the significance level, right? The p-value here is lower than 0.05. Reject the null, right? We said we rejected the null. The null must go away. So reject the null. There is sufficient evidence to support the claim that actresses are generally younger when they win the award than the actors. All right, now, last thing is they want us to go into a confidence interval. It says construct a confidence interval that could be used. In other words, the same kind of confidence interval. Well, we've got to figure out our percentage. Remember how we did that? Let's go to the notes. Suitable confidence interval. Well, it depends if you have an H1 not equal to or greater than less than. What's our H1? Our H1 is less than. So if your H1 is greater than or less than, the confidence level is 1 minus 2a. So, there we go. So our confidence level is going to equal 1 minus 2a. 1 minus, what's a? Right there. There's a is 0.05, the significance level. 1 minus 2, so 1 minus 2 times 5% is 10%, so that's 90% confidence level. So you got to do, so now what you do is you can do a, well, let's go back and look at our notes and you'll see. We're going to do, let me erase all my scribbles here. You're going to do a t-interval. You've already got the data in L3. It's nice. You don't need to go through any of that again. Just go right to t. We did t-test before. Now we're going to do a t-interval, confidence interval, t-interval. So we're going to go t-interval. So choose T interval, and it'll ask you data or stats, and you choose data, and when it says what list, again, notice this, L3, super important that you see that, L3 there, right, because that's where our data is, not L1 or L2. You got to make that L3. It's really important because that's where our list of data is. That's where the differences are, right? We stored all the differences, actress minus actor, in the L3 data set. That's our data set. Frequency is 1. The confidence level is, we decided 0.90, right? 90%. Remember how we came up with that? It's we decided that when your H1 is less than, it says for less than or greater than 1 minus 2a. So we did 1 minus 2 times 0.05, the significance level, and 1 minus, 2 times 0.05 is 0.10, 1 minus that is 0.90. So confidence level 0.90. Hit the buttons, hit calculate, and when you do, you'll get a confidence level that goes from negative 15.3 to negative 0.1. Now, what does that mean? Last thing, it's been a long problem. They want us to conclude what that means. They say, what feature of the confidence level leads to the same conclusion that you got in part A, which was to reject the null? Remember, this was equal to 0. This was less than 0. This was the claim. Anyway, so we rejected the null. So what about this confidence interval should make us feel the same way? Well, let me show you. So the key idea is that confidence level does not have 0 in it. See, it's all about whether you have 0 or not. That confidence interval goes from negative 15.3 to negative 0.1, doesn't it? Where's 0? 0 is somewhere right here. We are, 90% sure, right? 90% confidence interval that the real difference, if you took all actresses and actors who will ever, and from now until the future forever, who will ever win the Best Actor, Best Actress award, we are 90% sure that the true difference, if you took actress minus actor, for all actresses and actors who ever win the award forever, the true difference will be, we're 90% sure the true difference, based on our sample data, we're 90% sure that the true difference is somewhere in this zone, which is all negative numbers. 0's not in that zone. So we're pretty sure 0's not in that interval. We're pretty sure the difference does not equal 0. It's not a 0 difference. No, it's a negative difference, meaning the actress is younger. She's like 28 and he's 58. She's usually younger. That's why when you subtract them, you get a negative number. We're 90% sure that really the actresses are younger. 0 is not in that interval. Since the interval contains only negative numbers, we should reject the null, right? Because the null says equal 0. But no, 0 is not in that interval. So not equal to 0, only less than 0, only negative numbers. Same conclusion we got. So the confidence interval tells us only negative numbers, which gives us the same conclusion we got to part A, the hypothesis test. If you have only negative numbers, 0 is not in the interval, you should reject the equal 0 option. 0 is not in that interval. They can't equal 0. We're 90% sure it's less than 0. There we go. Okay, so I'm on to number 3. I skipped number 2 because it's the same. There's nothing new about number 2. It's just the same as number 1. Number 3 has a couple slight differences, so I want to go over this one with you. So again, noticed here, these are 8 different randomly selected couples. So they're not just 8 males and 8 females totally unrelated. They're couples. So this is a male-female couple. It's a male-female couple. So that's clearly matched pairs, isn't it? Matched pairs. So in other words, it's dependent data. They're connected. They depend upon one another. They're not just 8 random men and 8 random women. They're 8 couples. So the amount of words they speak, this is all about who speaks more words, men or women, is going to be connected in some way. So we use matched pair data. So you know what to do from before. Let's go look at our exam 4 notes. Here it is. This is again exam 4 notes, and it says to dependent matched pair means put the data in L1, L2, and then do the L1 minus L2 stored in L3 thing. So let's go there. So you put this data in L1, this data in L2. Remember how to do that. You hit Stat, Edit, go to the top of L1 and hit Clear and Enter, and then put the L1 data in, and L2 do the same thing. So put in your L1, L2 data, and then hit Second, Quit, get out of that menu, and then hit L1 minus L2 stored in L3. L1, you do that by second 1, and L2, second 2, L3, second 3. So L1 minus L2, store the differences in L3. L3 will hold the differences, L1 minus L2. So again, we're looking at the differences, right? We're taking, you don't have to do this, but this is what our computer calculator is doing for us. It's taking 15,000 minus 23,000, getting whatever that is, minus 8,000, I don't know. Maybe I do know, 740, you know, and on you go, etc. Just subtracting the number of words the man in the couple speaks minus, right, it's a difference, minus the number of words the female, the woman in the couple speaks, etc. Just keep doing those differences. Find out if those differences tend to be negative or positive or what. All right, now what's the claim? We're ready to talk about claim, most important part of the problem. Where does it say claim? Test the claim that among couples, males speak fewer words than females. Now, what does that mean? Males speak fewer words than females. Well, here we are on a fresh screen. I want to help you with that. Males, fewer. Fewer means less words than females. That's, oops, I'm spelling females right. That's the claim. That's what's being claimed. Okay, so the males, that's list 1, and the females are list 2. So we're saying mu1 minus mu2. What does that mean if the males are less? Well, here, I don't need to write it that way. If the males are less, if you're subtracting them, if you're taking the difference, you're going to get the differences down here, right? The differences. And if the males are less, males are fewer, less, then like this male is less than than the female in this couple, you get a negative answer, negative 8,000 whatever, 740, when you subtract. If the male number is lower than when you subtract and get the difference, L1 minus L2, that's what we put in L3, right? You'll get negative differences. So the differences will end up being held in L3 because we stored it, right? Remember back here, we did L1 minus L2 stored in L3. So L3 holds the differences now. So if the males are less than the females, like this male is less than this female, the differences will tend to be negative. So that's the claim. All right, well, you know this is always equal. The null hypothesis is always equal. And so we're claiming that the mean, that is the Greek mu, the mean of the differences is if the males are less, then males minus females. If this number is less and this number is more, then when you subtract them, you'll get something negative, meaning less than 0, right? If the male, like this male number here, this is less than this, when you subtract, you get something negative. Less than 0 is another way of saying negative, right? If a number is lower than 0, it's negative. So the claim is less than 0. That's the claim. The claim is that the difference is less than 0. The difference, male minus female, is less than 0, and the alternative is always equal, so that'd be equal to 0. So here's the claim. The claim is this one. All right, let's go to our calculator. What are we going to do? So looking back, right here, put the data into L3. We did that. T-test. Data 0L3. So we're going to go T-test. When we go to T-test, it's going to ask, and then we're going to choose data, not stats, because all of our information is in a data table. And what data table is it in? It's in L3, right? The differences are all in L3 now. So when they ask, first off, they ask us mu0 on our calculator, and that little sub-0 tells us you just grab the number with the H0, which is 0. And then when it says, where's your list of data, remember, this is the part that's different. It's L3, not L1. That's where our data is. It's the differences are all in L3. And then they ask us frequency. That's always 1. And this one's a less than 0, so we choose less than 0. Hit calculate, and I'll tell you what I'm getting here on number 3. I'm getting the t-value is negative 0.53. And I'm getting the t-value, and then the p-value is 0.308. All right, so what does that mean about our conclusion on this matter? Okay, so what does that mean then about our p-value? This p-value is greater than the test statistic. Where is our test statistic number? Oh, it's covered up by my thing here. There it is, 0.01. So that's certainly, way greater than 0.01. So if the p is not low, which it is not, it's greater, right? This p-value is greater than the significance level. P is not low. The HO does not go away. So we keep the HO. We keep the, oops, that's right here, the null hypothesis, which says that the differences are equal to 0. What does that mean if there's no difference? The difference is 0. The difference equals 0. So the male-female word count is actually equal to 0. The difference is 0, meaning they're the same. At least, remember, that's weak evidence. So at least there wasn't strong evidence in these couples, these 8 couples. There was not strong evidence that the women talk more, that the men talk less. There was not strong evidence. So since the p-value is greater than the significance level, we fail to reject the null. Fail to reject the null. There is not sufficient evidence to support the claim that males speak fewer words in a day than females. Right? The evidence came out 2 weeks. There was a 31% chance the results were just luck. They weren't that different. So the evidence was weak. We stick with the null, which says the difference is 0, meaning there's no difference. All right, now we need to do the confidence interval. So let's do that. So let me go to a fresh screen here. So now for the confidence interval. So how do we know what confidence interval we're going to do? Remember the information here, suitable confidence interval. It all depends on your H1. What's our H1? I don't remember. Our H1 is a less than. So our H1 is less than. So it's here. H1 is less than, greater than or less than. You do 1 minus 2a. So we're going to do, so H1 is less than. So the confidence interval is 1 minus 2a. What's the a? 0.01. That's the a, the significance level, 0.01. That's the significance level on this one. So this is 1 minus 2 times 0.01. This is 1 minus 0.02. This is 98%. So we got to do a 98% confidence interval. So you know how to do it now. Going back here, you go to T interval. All the other information is already there. Choose data, 0, L3. So let's do it. So T interval on our stats menu. Choose data, and the list, where's our data to be found? L3, right? Make sure you're aware of that, not L1. The data is all in L3. That's where we put all the differences on these matched pair problems. Frequency, that's always 1. The confidence level, again, 0.98, because we just calculated it here. Hit calculate, and I got a confidence level minus 12,392 up to 8,695. Okay. So what does that mean? Let's draw that confidence interval. That means that between negative 12,392 and positive 8,695, and by the way, zero's in there. Zero's about right here, isn't it? So we are, what? 98% sure. 98% sure. That the true difference between all men and women, words spoken in a day, the true difference is somewhere between negative 12,000 and positive 8,000, which means zero is in the interval. So the difference could be 0. So we're not sure it's not 0. It could be 0. So that's why. So since the confidence interval contains 0, fail to reject the null. Remember, the null said that the difference equaled 0, and the alternative said that the difference was less than 0. Well, the difference could be 0. 0 is in the interval. The confidence interval says we're 98% confident, sure, that the difference is somewhere between negative 12,000 and positive 8,000, which means it could be 0, which means the null is still a possibility. We couldn't rule it out with strong evidence. The difference could be 0. So we failed to reject the null. We got to keep the null. The confidence interval is telling us the same thing. What we're confident about is the same result that the hypothesis test told us, that we got to keep the null. There's just not strong evidence. We're sticking with the fact that the difference is 0. Men and women could be speaking the same amount of words. There's just not strong enough evidence to conclude that the men are speaking fewer. Okay, so here we are on number 4. Systolic blood pressures taken from the right arm and the left arm of the same woman. So this is woman number 1. I'll just say W number 1. Or I'll say woman 1. And this is woman 2. And this is woman 3, woman 4, woman 5. So that's the right arm and the left arm for 5 different women. So clearly, these data are matched pairs. They're connected. The data are certainly connected. It isn't like we took the right arms of 5 women and the left arms of 5 totally different women. Then the numbers wouldn't be matched up. They'd be independent samples. That would have been a problem from last section, 9.2. But these numbers are matched. They're dependent. They're related. They're connected. This number is connected to that number because it's from the same woman. So this is matched pairs data dependent. That's how we recognize that on the exam. They're all matched up. I think it's pretty clear when you look at it. All right, let's see what we got here for claim. I don't see the word claim. Do you? Where is that? To test. There's the word test. I don't see the word claim, but use a 0.05 significance level to test. To test what? For a difference. So that's what we're testing for. The claim, the test, is for a difference. Now, what does that mean, difference? Remember, these matched pair problems are all about calculating the differences. So we're going to come down here. We're not going to do it by hand. The calculator is going to do it. But we're going to subtract, and we're going to get the differences. Right? We're going to take 144 minus 84 and get minus 84. We're going to take 143 minus 63 and get minus 20. We're going to subtract these and get minus, I don't know what that is, 54. Subtract these and get minus 21. Subtract these and get whatever that is, minus 13, I think. Anyway, we're going to get some differences, and we're going to put those into L3 eventually. So what are we claiming? They're saying you're testing for a difference. That's kind of a weird way to say that. What does that mean, a difference? Well, what if there's not a difference? What does that? How about we do the opposite question? What does it mean to not be different? Well, that would mean their difference is 0. So if you're claiming that there is a difference, you're claiming that the difference is not equal to 0. That's what you're claiming. I know that's kind of probably a little weird. Let's come down here and write. So the mean of the differences, we're looking at this group of differences here. We're saying the average of those differences, remember the null hypothesis is always equal, and the alternative in this case is not equal to 0, and that's the claim, right? Because that would be a difference. If the difference is not 0, then they're different. There is a difference. This is what it means to be a difference. A difference is when the difference is not equal to 0. Whereas if the difference is equal to 0, they're the same, aren't they? If you subtract them, get their difference. If you subtract 2 numbers and it comes out 0, that's because those numbers are the same. So if the difference is 0, they're the same numbers. But if the difference is not 0, they're different. Right? That's what they're saying. Test for a difference. Test to see that the difference is not 0. Okay. So you know what to do with your calculator at this point. You put this data here into L1, put this data into L2, and then this data, the differences will get in L3. How so? Because you put data in L1 and L2, and then you go second, you quit out of that main screen, and then you go L1 minus L2 stored into L3. Remember all that? You get L1 by going second 1, and you get L2 by going second 2, and L3 by going second 3. So you store the difference. So the differences now will be in L3, and we'll just work with L3. We no longer think of it as 2 samples. All of our data that we care about is from the 2 samples is now stored in one data set, L3. So we go to t-test, stat tests, t-test, and then it says, and then we choose data instead of stats, choose data, and then it says what's mu0. Mu0, where do we always find mu0? It's that little sub-0 is like the sub-0 here. It's the number from there, which is 0. It's the number next to the null hypothesis. That's what the mu0 is to remind us of, the null hypothesis with the sub-0. It's the number on the null hypothesis. And then the list, where's our list of data? L3. not L1 again, right? That's where our list of data is. All right, frequency, always 1. And we're choosing not equals this time. Choose not equals, calculate, and I got test statistic, t value negative 3.91, p value 0.017. Okay. Now what does that mean? That number is, let me get this out of the way, move it up. That was up here. Anyway, that number, what was my significance level on this one? Right there, 0.05. That's certainly less than 0.05. That's a very low number. So so when the P is low, the HO must go away, right? The P is low. There's a low probability of luck, really low. We don't believe this is luck. We do not believe the HO. We believe this evidence is strong. This is strong. Remember, the H1 is always strong evidence. We believe the evidence is strong because the chance of luck, the p-value, the probability of luck is so low. We believe this is not luck, that this is a real difference between the right arm and the left arm. Look at these differences. They all came out negative. I mean, that's strong evidence. That's why the probability of luck came out so low. There's no way that could just be luck. They all came out significantly negative. So that's strong evidence that the difference is not equal to 0. They really are different. The claim is right. Since the p-value is less than the significance level, reject the null. There is sufficient evidence. There's enough evidence to support the claim that there is a difference in measurements between the arms. There's definitely a difference. There we go. Okay, so here we are in number 5. Data on the numbers of hospital admissions. Okay, so basically there's the idea that, hey, on Friday the 13th, maybe there's more hospital admissions, because people feel weird about that day. Well, specifically when the 13th day of the month falls on a Friday, yeah. So Friday the 13th, this is numbers of hospital admissions. So we're going to test the old rumor that Friday the 13th has some special significance and more people go to the hospital because of accidents on Friday the 13th. So here is, we're comparing Friday the 6th with Friday the 13th. We're picking both Fridays because, Friday is a certain kind of day when people go out a lot and accidents could happen. So we want to compare Fridays with Fridays. But let's compare Friday the 6th with Friday the 13th for various months. So there were 3 hospital admissions on that Friday the 6th, and 1 week later, Friday the 13th, 11 hospital admissions. So, hey, that was higher. 2 compared to 10, but these were the same, 2 to 10, 11 to 14. Looks like there's a few more happening on Friday the 13th. So we'll see how the data pans out. So you know what we're going to do. These are certainly paired data. Why? Because Friday the 6th of a month and Friday the following 13th, same month. So see, these are paired data. They're dependent. They relate to one another. So you know what we're going to do. We're going to put this data set into L1, the bottom data into L2, and then we're going to, the differences between them, -8, right? Top number minus bottom, we're going to subtract. Top number minus bottom, -8, 0, -8, -3. Going to subtract. That's going to go into L3, and we'll do our data analysis all from L3. So we go to stat. Well, here, I'll just skip all that, and I'll say put data into L1 and L2, and then quit out of that and go L1 minus L2 stored into L3. So now the differences are in L3. Now in this problem, they just want a 95% confidence interval. So you know what you do? You just go to your calculator and you go T t-test, right? Getting all this off the exam 3 notes. So we'll just do t-test on our calculator. I'm sorry, the exam 4 notes. That's where, oh, not t-test, t-interval, huh? There's a confidence interval. So I'm going to go down to t-interval from the exam 4 notes. It shows all this stuff. Choose data, and the list is L3, right? Not L1. Our data, the differences are now in L3. The frequency is always 1. Confidence level, we're doing a 95%. So you do a 95%. Hit the buttons on your calculator. It'll tell you, here's what it told me, negative 10.01 to negative 0.79. So, all right, so that's where my confidence interval came out to be. Now, what does that mean? So that means if you take the number line, that's going from negative. It says based on the confidence interval, can one reject the claim that when the 13th day of a month falls on a Friday, the numbers of hospital admissions from motor vehicle crashes are not affected? Can we reject that claim? Do you understand what they're saying? Let me get this out of the way. They want us to reject that the 13th, reject the idea that the 13th crashes, the number of crashes is not affected. They want me to reject that. Can I? No, they want me to conclude. They want me to conclude that on the 13th, the number of crashes is affected. That it makes a difference on the 13th. It is affected. That's what they want me to conclude. Can I? From this confidence interval. And the answer is yes. Here's why. Let's look at the confidence interval. Right? It goes from negative 10.01 to negative 0.79. Where's 0? 0's over here, right? And positive numbers are over there. So we are what? We're confident. We're 95% sure, 95% confident that the real difference, if you take all Friday the 13th forever compared to Friday the 6th, and you take the difference, you subtract them, the differences, we're 95% sure based on these 5 different, 1, 2, 3, 4, 5 different weeks. This data set, the sample data, based on the sample data, we're 95% sure that the real true difference is somewhere between negative 10.01 and negative 0.79, meaning it's not 0, because 0 is out here. We're 95% sure that the difference is not 0. Right? If the difference is 0, that would mean they are the same. Right? If the difference is 0, then they're not different. But we're 95% sure that the difference is not the difference. The difference is not 0. They are different. The number of crashes is affected. The number of crashes is different. So can we do that? Can we conclude that? Yes, D here. Yes, because the confidence interval does not include 0. We can conclude that. Okay, so I'm going to leave number 6 and number 7 to you. It's the same thing as number 5. They're just 2 confidence interval tests, and then in the end, it's all about whether 0 is in the interval or not in the interval, right? If the difference is 0, then they're the same. So if 0 is in the interval, they could be the same. If 0 is not in the interval, then we're 95% sure they're not the same. That's going to be the conclusion on confidence interval and what it means.